The next part of this handout is talking about the period, and the period of a function is the horizontal distance it takes for the pattern to repeat itself. It needs to be able to take on all of the y values that are in the range and then start repeating. So the period of sine x and cosine x is 2 pi. We've talked about that before when we were looking at our functions in the last chapter, and actually even in chapter 1 when we talked about coterminal functions. So this is, again, the general form of the equation for a sine function that our book uses, where we have b to be positive, and the period is then going to be 2 pi over b. There are other forms for the general equation of sine and cosine function that other books use, and some of our homework problems in this unit actually use that other form when they do their explanation on how to get the right answer. If you look at view an example, they will actually use a different formula than what our book is using. So be sure that you use the formula that we're using here. And the period is 2 pi over b. That's the formula that we're going to be using. Problem number 7, determine the period of each of the functions graphed below. Okay, so I'm going to start here at the origin, and I'm going to look at my graph here going toward the right. So I'm going up and I'm going down here, and I want to figure out, when is one complete cycle? I need to do this bottom part, and then I need to come back to here. This would be one complete cycle until it starts repeating itself. So that is one period. But what I've highlighted there in pink is one period. And let me see if I can color code this. Let me do something else before I start color coding stuff. If I want to know what this period is, I need to know what this point right here is. So I'm going to look at the graph this way. I've got this part in red. I've got this part here in green. And I've got this third little section over here in blue. So those 3 sections are evenly divided. They're evenly spaced out. And this is pi is where they end up. So if I look at this x-intercept and this x-intercept, this is 1/3 of my graph. So this is 1/3 pi, or pi over 3. This is 2/3 pi, or 2 pi over 3. And this is 3/3 pi, right? 1/3, 2/3, 3/3. So this point right here is 2 pi over 3. Any questions on how I got that point? I think it's easy to draw out your part that's highlighted there in pink. The tricky part is figuring out what that point is. Okay, so let me go back up here. Determining the period of each of these functions. Basically, what I'm figuring out is how long does it take for the graph to start repeating. And it's at this point here that it starts repeating. Well, that point is the 0.2 pi. Another way that I could look at this is to figure out how many cycles are there in 2 pi. So I know that on a circle, 2 pi is 360 degrees. That's once all the way around. So if I had this peak part here, and then I did another thing here, say in yellow, and then I did another one here in green, I would have 3 complete cycles in 2 pi. I have 3 cycles in 2 pi. I guess I could go ahead and highlight that. Not sure if this is going to show up in the color that I want it to. This is supposed to be green, and it's showing up as yellow. And then I would have this here is my third one, and that shows up as yellow as well. That's supposed to show up as yellow. Make this to be darker. I'll make it darker. Maybe it'll look a little bit more green. All right, so you can see I have 3 complete cycles here. Do it this way. Make it darker on black. Right, so I got the pink, the black, and then the yellow. So I have 3 complete cycles in 2 pi. So each cycle then is 2 pi over 3. So there's 2 different ways that you could get that answer for the period. My suggestion to you is to use this first method. How long does it take for the graph to start repeating? And that's what we're going to do over here on these next 2 problems, is to figure out maybe a little bit better way other than just drawing this in, because it doesn't always work for every problem. So here, I'm going to start at the y-axis. I'm going to go down, and then I'm going to come back up, and then that's where it starts repeating again. So I'm going from this point to this point. So I'm going from 0 to pi. So my period is pi. Okay, so if I look at this next graph, if I start here at the origin, I go up and then I come back down, and I'm starting to go back down again, but I know that my graph is not completed here. Right? I need to go back down and then start to come back up again. So by starting here at the origin or the y-axis, I'm really not getting my whole graph. I need to sort of back up and use this point to this point. So here, I start at the x-axis, I go down, I come back up, go to the top of the mountain, and then I come back down. Now I'm going to start repeating again. I'm at my x-axis, and now I'm going to start to go back down. So this whole distance here from -4 pi to +4 pi is my period. So from -4 pi to +4 pi is 8 pi.
I want to talk a little bit more about how we can determine the period from this function. I know that the distance between -4 pi and the y-axis is 4 pi units, and the distance between the y-axis and 4 pi is another 4 pi units. 4 pi and 4 pi is 8 pi. So my period is 8 pi. But I want us to look at a different way to get that answer. If I can determine a starting and ending point for the period, then I can use this formula, the bigger number minus the smaller number. So in this case, I have 4 pi minus -4 pi, and that's going to be positive 8 pi.
Okay, when you are looking at the period, You can go from max to maximum. All right, so like from this mountaintop to that mountaintop. I can go from a minimum to a minimum, right? The bottom of the valley here to the bottom of the valley here. I can do that if I want to. You cannot go from x-intercept to x-intercept, right? So if I were to look at, excuse me, this problem over here that I just did in pink, right? Here's an x-intercept. If I go from x-intercept to x-intercept, I have not gone one complete cycle because I would then be leaving out all of these values here where the y coordinate is negative. So you can't go from x-intercept to x-intercept when you're looking at period. You can go from max to max, min to min, but not x-intercept to x-intercept.
Just to clarify what I'm talking about with the x-intercepts, I can use x-intercepts to find my period, but I have to be careful about which x-intercepts I'm using. I can't just pick any x-intercepts. And you can see here the two intercepts that I have marked in green. I did that in a previous problem. I can use those two x-intercepts to help me determine my period, but I can't, for instance, pick this x-intercept because that is not one complete period. So just be careful with that.
The formula for the period is 2 pi divided by b. So this is the formula that we're using here. Period is 2 pi divided by b. And remember that we're looking at this as my general form for my equation. So it's the coefficient of this x term. So this period here is 2 pi over b. So in this case, it's 2 pi over 2. The 2's cancel, and that's pi. Questions with that? Okay, so problem B here is where it starts to get a little bit more interesting. Period. I'm writing down my formula. The best way to memorize your formula is to write it down every time you use it. And that's also the best way to help you understand where your answer is coming from, is to be sure that you're understanding that formula. So I have 2 pi divided by pi over 4. So I need to simplify that problem. And there's two different ways that I can simplify this. First thing I'm going to do is to look at this like just a regular old complex fraction. So I would multiply the numerator and denominator by the least common denominator of my smaller fractions. So I only have one small fraction here, right? My fraction within a fraction, and its denominator is 4. So multiply top and bottom by 4. So in the numerator, I'm going to have 8 pi. In the denominator, the 4's cancel. That's pi. And then the pi's cancel. So my final answer here is 8. Any questions with that so far? Okay. I'm going to turn on the very back of this handout, and I'm going to do this problem a little bit differently. I'm still going to be looking at 2 pi divided by pi over 4, but in this case, instead of multiplying my numerator and denominator by 4, I'm going to write this out like you would write out normal division of fraction problems like you learned in elementary school. Now this is 2 pi divided by pi over 4. And remember that when you are dividing fractions, you can invert and multiply. So then I would have 4 over pi. And if you want to, you could write this over 1 so it's easy to see. I have pi in the numerator and pi in the denominator, and they would cancel. So then you just have 2 times 4, which is 8. It doesn't really matter to me which way you do these problems, but if I were y'all, I would try to get used to working the problems this way, because this skill of multiplying numerator and denominator by your coefficient is going to be a skill that you're going to use throughout calculus. We're going to see it again when we do some problems from chapter 3, but you're going to see it a lot in calculus. So I would get used to doing the problem that way. Any questions with that so far? Okay, I want y'all to try those next 2 problems on your own. I'll do that on the roll. Okay, here we have 2 pi divided by b, so 2 pi divided by 4 pi. Remember that this is the b, the coefficient of your x term, so 4 pi divided by, or 2 pi divided by 4 pi, this cancels, so 2/4 simplifies to 1/2. Notice that there's not a pi in my answer, right? Sometimes you have pi in the answer, sometimes you don't. In that case, I don't. Here I have 2 pi divided by 1/4. I'm going to multiply numerator and denominator by 4. So I have 8 pi over 1, which is just 8 pi. Any questions with that? Okay, the next problem asks us to graph the equation y equals sine of 2x. I know that my period is 2 pi divided by 2, so my period is just pi. That means I'm going to have 2 complete cycles in 2 pi. So I've got 1 complete cycle in pi, I've got 2 complete cycles in 2 pi. And I think the best way to do this, without a calculator here, is to make a table of values. Whether you're graphing a linear equation, a quadratic equation, some kind of weird equation, is to make a table of values. So I did not leave myself a whole lot of room here. I'm going to try and squeeze this in over here. Making my table of values here. So I'm going to start off with 0. So I'm going to have the sine of 0, and that is 0. So if you're thinking about this on a unit circle, remember sine is your x coordinate. So I'm sorry, sine is your y coordinate. So this would be the point 1, 0. So I have 0 here. And let me put in, I'm going to go ahead and put in pi over 4 for x. So I would have the sine of 2 times pi over 4, and that's 1/2 pi. So the sine of 1/2 pi is 1. All right, so here I go up to 1. And then if I put in pi over 2, I would have the sine of 2 times pi over 2, which is the sine of pi. So I'm over here at 0 again, right? And that's where I'm supposed to be, because my graph's telling me that I should have 1 complete cycle here. Okay, so this would be my half of a rotation or half of a cycle, and then I go up here and I'm going to come back down here and then up again. So that would be 2 cycles here into 2 pi. You are not going to have to make a graph on your own on a test, but you do need to be sure that you know how to look at a graph and figure out the period. And so it helps to make a graph or 2 on your own to be sure that you're understanding what's going on. And making this table is always a good idea to help if you're unsure about something.